So how about page 8? I want you guys to go ahead and fill out the degrees of that circle. Right on page 8. So you're given 0 degrees / 360. You're also given 30 degrees. Okay? That next tick mark after the 30 degrees is exactly halfway between 0 and 90. Okay? So that should give you a hint what the next one is. I'm going to pass out your assignment sheets for next week. Shannon said.
Yeah.
A lot of you already turned in test corrections, which is great. For those of you who have not, they're due on Tuesday. Get them in early though if you can. Passing back your quizzes. Overall, they weren't too bad. However, if you feel like you could have done better, everyone has the opportunity to retake it. If you feel like you could have done better, come see me at the end of class. I'll write you a pass. We'll have about 5 minutes to talk at the end of class about any specific questions on your quiz. Since it was out of 14, if you missed one, you got a 13 out of 14. You're already at a 92. If you missed 12, you're already at a 86. You got 12 out of 14. So, if you feel like you can do better, there'll be a very, very similar setup. You have to do 8 sketching angles. Half of them would be positive, half would be negative, and then filling out the angles at the top. No penalty if you want to retake it. I'll be coming around to check that you have your special right triangle packet completed. So have that out, the first 2 pages of that yellow triangle packet. Also, when you're done doing all the degrees of your circle, when we're given pi over 7, I want you to find the complementary angle to pi over 7 and the supplementary angle to pi over 7. First 2 pages done. So try labeling that circle in degrees. You want to do on the top of that sheet or on the back. Find the complementary angle and supplementary angle to pi over square root. So a lot of you have already turned in corrections, which is great. If not, those are due on Tuesday. Does anyone need help right now? That was 45. That's correct. We're all correct. They're all correct. Don't doubt yourself.
No.
Because the kid printed 3 extra pages.
I actually, we actually, like literally just like decorated this whole week in front of everybody. And he was like,
I'm sorry, he's
here.
not told you.
It's like, you could have used it there. He was like, what are you talking about? I can't stand that when I'm old.
I really asked him, he was good. And then I didn't say, he was like, what did you say? I said, I said, you gotta check my thing, which is like spine.
Yeah.
I didn't say anything.
I don't understand why you guys don't do anything. I don't understand why you don't know anything. It's like you do one example and then soon you're asking for 90.
Yeah.
I don't act like one part. Like you don't even teach.
Yeah.
Sorry, I've never thought about my locals that actually are my bad. Rest of them are like,
Yeah, I know.
it's ridiculous. I can't. I don't. I just try not to say a word. It's like, it was popular. Nice.
anyone try the complementary and supplementary? Yes, no, maybe so. Complementary. Complementary means what? So they have to add up to how many degrees does complementary angles add up to? 90 degrees. What's that 90 degrees in radians? Pi over 2. So to find the complementary angle, pi over 7, I can say pi over 7 plus what angle gives me pi over 2. So if I subtract pi over 7 on both sides and make common denominators, I'll get 7 pi over 14 minus 2 pi over 14, which is 5 pi over 14. What about supplementary? How many degrees is supplementary? Morgan? 180. And Morgan, what would that be in radians? Pi. So you have to say pi over 7 plus what angle will give me pi. So I can subtract pi over 7 from both sides, and I make common denominators. So my supplementary angle would be pi over 6 pi over 7. I think I worked with almost all of you on the circle stuff. So for Monday, try putting those in radians. Okay. So let's look at our lesson, which I am. It is we're doing the bottom of page 7. So today we're going to look at arc length and what that means. Anyone heard of the word arc length before? Briefly just heard it. So arc length, if I'm given a circle here, not connected. If I'm given a circle, an arc length is like a specific portion of the perimeter. You can think of it like that. So here, if I draw a circle, from one point of our angle to the other, this specific part of that circle is an arc. So if I want to find this arc length or what that measurement is, I need to compare the radius of the circle with the angle that this circle makes, this angle makes. So theta, we're going to call this our central angle. And theta has to be in radians. So the relationship between our central angle, our radius, and our arc length is described by the formula S, which is arc length, is equal to the radius times that central angle theta in radians. Okay? So arc length is the radius times the central angle. Not the hardest formula ever. Pretty straightforward. If I want to write a formula, if I'm asked to find the central angle would be the arc length divided by the radius. So you can use either one of these formulas depending on what the problem asks you to find. Okay. So we just have 2 quick examples today, nothing too crazy. If I'm given a circle that has a radius of 4 inches, and I'm asked to find the arc length when we have a central angle of 240 degrees. So here I'm given my radius, that's 4 inches. So that's what my R stands for. I'm asked to find the arc length, so I'm looking for S. I don't know what S represents. But I'm told my central angle is 240 degrees. Yes, Gavin? So if I'm asked to find 240 degrees, Like I said, this formula only works when our angle is in radians. But we know how to convert from degrees to radians. What formula, or what is the conversion to go from degrees to radians? Who remembers what we can multiply by? I'm given 240 degrees. What can I multiply by to get to radians? Pi over 180. So if I take my 240 and I multiply by pi over 180, I can write what this angle measurement is in radians. So this is the same thing as 240 pi over 180. So 240 degrees is the same thing as 4 pi over 3 radians. I now can use my formula. Arc length is equal to the radius times the angle measurement. So I can take 4 inches times my angle, which is 4 pi over 3, to find my arc length. That would be 16 pi over 3. So let's write that. Let's find the decimal approximation here, just because for measurements, I'm not really sure what that is right off the top of my head. So if I were to do 16 times pi in my calculator, then divided by 3, my arc length is approximately 16.76 inches. So if my radius is measured in inches, we're going to measure our arc length in inches. If our arc length is measured in feet, we're going to measure our radius in feet as well. Our arc length and our radius will be in the same measurement. Any questions? Okay, so if I'm asked to find the measure of the central angle of a circle with a radius of 9 inches, so here that says R is 9, and we're given an arc length of 20 inches, so my S is 20, I'm asked to find what my angle is. So if I know my arc length is the radius times my central angle, well, I can say my central angle is going to be my arc length divided by my radius. I've given those two pieces of information. So here, my arc length is 20 inches, and my radius is 9 inches. Theta, which is my central angle, is going to be approximately 2.2 radians. It's 2.2 repeating to be exact. The last thing we're asked to do is convert from radians to degrees. So I'm asked to take my central angle that I just found and convert them to degrees. What can I multiply 2.2 by to find that measurement in degrees? Go ahead, Josh.
180 over 5.
Multiply by 180 over 5. Someone put that in their calculator for me. Give me the approximation. Morgan, do you have it?
127.
So about 127 degrees. Any questions? Let's do presentations then, and then we'll go over the triangle packet. I have Gavin, Becca, Morgan, and Melina presenting 18, 24, 71, and 77. Okay. Who's up first? Gavin, you have number 18. Does anyone else have number 18 that would like to present? Okay, so number 18 asks us to say what quadrant 3.5 lies in and 2.25 lies in. So for 3.5, I know pi is the same thing as 3.14. So 3.5 is just going to be a little bit bigger than 3.14. So that would lie in quadrant 3. Okay. Then 2.25, again, if I have pi is approximately 3.14, 2.25 is just a little bit smaller. So that angle would lie in quadrant 2. Remember, it moves counterclockwise. Up here is 1, 2, 3, and that's our fourth quadrant down at the bottom right corner. Any questions on 18? Okay. Back that, you have 24.
For 24, you had A, which was 2, and then you had to see where it would lie, and it would lie in the second quadrant. And that'd be between 1.57 and 3.14, so you had to convert, and it'd do kind of like a halfway kind of thing. And then B is 5 pi, and 5 pi doesn't fit on the graph, so you have to go around 3 times.
Not exactly 3 times. 2.5, yeah. Because 1 time would be 2 pi. 2 times around the circle would be 4 pi. So 5 pi would be halfway around the circle again. Morgan, you have 71.
So it gave you negative 125 degrees and then 36 seconds. And I know that because of the double prime. So you have to put 36 over 3600, which simplifies to 1 over 100. And I know as a decimal, that's 0.01. So you get negative 125 over 0.01.
So there they didn't give you minutes and seconds, they just gave you seconds. You can do 36 over 3,000. And Melina, do you have 77? I think we're going from radians to degrees, minutes and seconds.
I forget what they gave you first, but I just plugged that into the calculator, and then you got 0 degrees, 21 minutes, and 18 seconds.
So let's look at this. Our original problem was we're given negative 0.355. I have a feeling you thought that was degrees.
Yeah, I probably did.
But negative 0.355, since it doesn't have the degree symbol, that's actually in radians. So let's think this one through real quick. If I'm given negative 0.355 radians, what would I have to multiply to convert that to degrees? 180 over pi. So when you do that, you should get approximately negative 20.434 degrees. Okay. So when you go ahead and put that into degrees, minutes, and seconds, you get negative 20 degrees. And this is just from your calculator. Negative 20 degrees, you get 20 minutes, and I got 24 seconds. this would change a little bit how you round it. But remember, if that degree symbol's not written, we have to write it. We have to convert it to degrees first. Other questions on that homework assignment? So I have 4 presenters for Monday. Ashley, 91. Morgan, 99. Josh, 104. One more. Tess, 106. Last thing, we'll spend the last couple minutes going over the special right triangle packet. So pull that out. Sure. So I saw a lot of circled questions. So what problems do you want to go over first when I was walking around? If you did not finish this, please have it out and write a couple problems down. 7 on the first page or the second page? So number 7. I'm given a triangle and it is a 30, 60, 90 triangle. I'm going to go ahead and sketch this here. So if you remember a 30, 60, 90 triangle, our ratios when we're given that is if the 30-degree side is x, so if 30 degrees is just some side length x, to get our 60-degree side, we can take x and multiply it by the square root of 3. Then to get my 90-degree side, I can take my value of my 30-degree side and multiply it by 2. Okay. So here, Becca, in problem 7, are we given the 30, 60, or 90-degree side? 90. So 90-degree side here is 8 times the square root of 21. So we have to work backwards a little bit here. To get my 30-degree side, to go from 30 to 90, I multiply by 2. So to go from 90 to 30, what would I have to do? Go from 30 to 90, we can multiply by 2. To go from 90 to 30, what could we do? Yeah, I can take 8 times the square root of 21 and divide by 2. So my 30-degree side is going to be 4 times the square root of 21. That's going to be my value of x. Okay. So to go from my 30-degree side to my 60-degree side, what am I going to have to do then? Yeah, so I'm going to do 4 times the square root of 21 times the square root of 3. So that is 4 times the square root of 63. The only thing there is we can simplify a little bit. What perfect square is divisible? 63 is divisible by what perfect square? Yeah. 63, that's the same thing as the square root of 9 times the square root of 7. And the square root of 9 is 3. So my 60-degree side is going to be 12 times the square root of 7. Does that help clarify? Other questions? You still want me to do number 7 on the... Okay. I saw circled problems. Josh.
Go over number 6 on the second page.
Yes. So it's a 30, 60, 90. And Josh, what side length are we given?
One opposite.
Yeah, so we're told our 60-degree side is 15. So to work backwards, to go from 30 to 60, I have to multiply by the square root of 3. To go from 60 to 30, what would I have to do? Yeah, I'm going to take my 60-degree side and divide by the square root of 3. The only thing there is 15 over the square root of 3 isn't very proper, so we have to rationalize the denominator. So when I multiply by the square root of 3 over the square root of 3, I get 15 square roots of 3 over 3, which in return simplifies to 5 times the square root of 3. That's going to be my 30-degree side. What would be my 90-degree side then? To go from 30 to 90, what can I multiply by?
2.
Yeah, so I'm just going to take this and multiply by 2, which is 10 times the square root of 3. Have a great weekend. If you did not finish your test corrections, make sure to have those for Tuesday. Look at the book work. If you want to retake that sketching English quiz on Monday, let me know. I'll write you a pass right now. Have a great weekend.
Did we present? Because I don't remember presenting this. I think it was, if I'm correct, Tuesday somewhere.
We didn't present it.
All right.
We ended up not presenting.